This is the next section, neutralization reactions. So a neutralization reaction is just a reaction between an acid and a base. It results in an ionic compound. And a salt is a generic word for that ion compound. So typically if I were to say the word salt, you would think of sodium chloride. But sodium chloride is a specific salt. A salt is simply just an ionic compound. So whenever I react an acid plus a base, I get water. In most reactions, we're going to see an exception to this, plus salt. So if I have hydrochloric acid plus sodium hydroxide, it's a double replacement reaction like we did with the precipitations. The sodium and the chloride bond together. You always write the cation, or if it's written on the left to start with, it stays on the left. So that becomes sodium chloride, that's my salt. And then the H goes with the OH to make water. Nitric acid plus sodium hydroxide, again, this H goes with this hydroxide to make water. And then the sodium plus the nitrate, and again, sodium written on the left stays on the left over here to form sodium nitrate, which is also a salt. So in this problem, we're going to do write the balanced reactions, molecular equations, including the phase labels, and then write the net ionic for each of them. So this is a double replacement. So I'm going to write aluminum and chloride. Aluminum's the left over here, so it's going to stay to the left. Chloride's the right over here, so it's going to stay to the right. And I'm going to do this in stages because we're going back to like we did it in nomenclature. So this is Al3 plus. That's from the fact it's in group 3 on the periodic table. And chloride, which is in group 7A, so it's a minus, goes to form AlCl3. So I don't get the subscripts from this side of the reaction. The subscripts come from the charges of the ions. And these are the same charges as we see over here. So when we first introduced ions, we talked about the crossing. The 3 here goes here. The fact that there's a 1 here goes there. This has no subscripts, so it's either 1 and 1, 2 and 2, but hydrogen being in the first row is a +1, chloride being in the last row is a -1. And this is going to be soluble, so AQ is the phase label, plus the HOH, if you would like to do it by double replacement, which forms water, and that's a liquid. So I'm going to rewrite this now as all one thing. So I have aluminum hydroxide, which is aqueous, plus HCl, also aqueous, goes to form AlCl3, aqueous, and I want to leave some room between here to write because I haven't balanced it yet. So the next step is to balance it. Water is liquid. So now I have it all as one line. I want to balance it like we did at the end of chapter 2. This is 1 aluminum, 1 aluminum. I've got 3 oxygens over here, and I've only got 1 oxygen over here, so I need to put a 3 here. I'm going to wait till hydrogens because hydrogen's here and here. So then I go to chloride. I have 1 chloride here, and I have 3 over here, so I put it into front of a 3. So the subscripts come from the charges. To balance it, you add the coefficients, just as a reminder. And now if I look at my hydrogens, I have 3 here, and I have 3 here, which is 6, and then 3 times the 2, which is a poorly written 2, but this is a 2, is 6. So it's a balanced reaction now. Now to write the net ionic, I need to first write out the complete ionic. So it's the coefficient times the subscript, or the number, so I have just Al. I want you to write a charge because that's what indicates the fact it's aqueous once I write it as a single. Plus 3 OH minuses. You have to recognize your polyatomic ions, again from chapter 2, because of the fact that stays together. Okay, plus 3H with a positive, plus 3 Cl's. So 3 times 1 is 3, 3 times 1 is 3. Goes to form, this one's aqueous, so it's going to form AlC, 3 plus 1 times 3 gives me 3 Cl minuses, plus as a liquid this stays together, so this is 3 H2Os. If it's not balanced at this point, it means it was not balanced at this point, or you made a mistake with the multiplication. So you shouldn't have to subtract here, okay? So it should either cancel out or not. So I have one aluminum and one aluminum. These are my spectator ions. 3 OHs don't exist over here. 3 H plus doesn't exist over here. And I have 3 chlorides, which has an ion, and 3 chlorides. So then to get the net ionic, I write down what's left. 3 OH minus plus 3 H plus goes to form 3 waters. And because all of these have a 3 in front of them, the correct way to write this is just OH minus plus H plus goes to form water. And this is my net ionic reaction here. Okay, I want you to pause the video and try the next one on your own. Again, I have H. This is hypochlorite acid, so it's going to go, the hydrogen is going to go with the hydroxide, so it's going to be HOH, which of course is water, and it's a liquid, plus the ClO and the Sr, but Sr is written on the left, so it's going to be written on the left here, Sr, and Sr is in group 2A, so it's a plus 2, ClO, you need to know that from your polyatomic ions, but it's in group 7A, so it's a minus, so this becomes Sr parentheses ClO with a 2 on the outside of the parentheses, and this is aqueous. So I'm going to rewrite the whole equation now. So I have HClO aqueous plus SrOH2 or strontium hydroxide aqueous goes to form water as a liquid plus strontium hypochlorite Sr parentheses ClO2 aqueous. So now I need to write out the full ionic equation. Oh, I'm sorry. Next I need to balance it. I'm sorry, I missed a step here. Hydrogens I'm going to do last because they're in 2 different places, again with oxygen. So I'll look at the chlorines. I've got 1 chlorine over here, and I've got 2 chlorines over here, so I'll put a 2 in front of this. I've got 1 strontium and 1 strontium. Now I'll look at my hydrogens. I've got 2 here, and I've got 2 there, so that's 4. I only have 2 here, so I'll put a 2 in front of that. And I look at my oxygens. I've got 2 here and 2 here, so I have something wrong. What's wrong? Oh, I'm sorry. I looked at my oxygens wrong. It's hard to say, that doesn't add up. I got 2 here, which is 2, and 2 here, which is 4. I've got 2 here, but I've also got 2 here. This is what I forgot. There's an oxygen over here. So it's balanced. So now I'm going to write the full ionic equation. So I have 2 H pluses plus 2 ClO minus 1s plus Sr 2 plus 2 OH minuses goes to form 2 waters, which stay together, plus Sr 2 plus 2 ClO minuses. Again, the 2 came from 1 times 2. I cross out, I don't have H plus, but I'd have ClO minuses. I have an Sr 2 plus, so I'm left with 2 H pluses plus 2 OH minuses goes to form 2 waters. And again, all these are 2 coefficients, so the correct answer would be H plus OH minus goes to form H2O. And you'll notice that this net ionic and that net ionic are the same, and most of your neutralization reactions are going to have this, but not all of them. I have one more example here of sulfuric acid plus potassium hydroxide. I forgot to write the aqueous here when I type this in. This one's also aqueous. So the H plus is going to go with the OH minus, so I have HOH, which of course is water and is a liquid, plus I have SO4 and K, so K as a positive 1 charge, SO4 as a polyatomic ion with a 2 minus charge, so this becomes K2SO4, and that's aqueous. So now I'm going to rewrite the whole equation, so I have H2SO4 aqueous plus KOH aqueous goes to form water as a liquid plus K2SO4 aqueous. I'm not going to start with hydrogens because I've got them in two different places. A hint here, when you're balancing, I can treat that SO4 as a whole thing. I've got one here and one there, so I'll have to do that. Potassiums, I've got one here and I've got two there, so I put a 2 there. And now if I go back and look at my hydrogens, I've got 2 hydrogens plus 2 hydrogens is 4, so I need to put a 2 there. I'm not going to count this because I treated this as an entire entity. Okay, so the SO4 stays together as an entity. So I'm not going to count these oxygens when I count my oxygens. Okay, so when I look at this, I've got 2 more oxygens and 2 times 1 is oxygen. Again, this is the same entity over here. Oops, different color. And so I'm treating that as a whole thing because it's a polyatomic ion. Now, to write the full ionic, okay, it's 1 times 2 is 2 H pluses. That's an ion, so it's SO4, 2 minus, plus 2 K pluses, plus 2 OH minuses, goes to form 2 waters as a liquid, plus 2 K pluses, plus an SO4, 2 minus. 2 H pluses don't cancel, but my SO4 2 minus does. My 2 K pluses cancel. So I'm left with 2 H plus 2 OH minus goes to form 2 waters. And again, since they all have a coefficient of 2, it just becomes H plus OH minus goes to form H2O. Oh, and that's a really bad O. Okay, and so that's going to be the end of this video.